Hello everybody and welcome to this presentation about neural well guess for this workshop on ethical consideration for creative application in computer vision. My name is Louis Thierry from ENS Paris and I worked with Thomas Kerdreux from Zuse Institute in Berlin on this project. As you know, computer vision algorithms and especially neural networks and machine learning algorithms are being more and more used in creative application of computer vision, and these algorithms have several unwanted behavior. Some of them are already well documented, for example, spurious correlation. On this example, Lapushkin et al. Have realized 2 years ago, several years after the publication of the Pascal-Vogt dataset, that the source tag present in horse images was responsible for the classification decision of a neural network. And when you remove this source tag after having trained the neural network on the original database, it is not even able to classify it, to recognize it is a horse image. The adversarial example is another kind of unwanted behavior of machine learning algorithm in computer vision, and it consists of adding a very small but very specific noise to change the classification decision of a neural network, changing it, for example, from a panda to a gibbon. And these unwanted behavior are very important and very picky, as when they concern bias, and it meets then several ethical consideration. But here we would like to talk about another kind of unwanted behavior that is a bit more specific to creative application, and taking the example of image colorization. Image colorization algorithms seek simply to recover an information that is lost. When you convert an image from the color to the grayscale space, you lose some information. For example, on the bottom row, you see the red car, but this car could have been blue and it could have yielded exactly the same grayscale image, or you can change the background on the top right image of the sea, of the sky, of the rock. You can change the colors and still getting the same grayscale image. So there is no correct answer in this case. And the fact that we confuse the output of a colorization algorithm and the reality come from the fact that neural networks are very successful at these tasks. So you see that all the colorized image produced by this neural network algorithm are very plausible, and we tend to take it for reality. But be careful, it might not be the case every time, and this might have consequences. Here are two examples to illustrate this statement. On the top, you see a Boletus satanis, which is a poisonous kind of Boletus. Once converted to grayscale and recolorized with a neural network on the top right, you see that it looks much more like a Boletus edulis, a cep, which is a delicious and valuable mushroom. Here, after having converted to grayscale and recolorized, the reality underlying the photograph, the scene, is completely different and might have, in this case, very bad consequences. On the bottom, you see two small children holding two toys, one holding a toy warfare in a summer and in a warm atmosphere. And once converted to grayscale and recolorized, you see that the orange band has disappeared from the toy warfare, then letting the people to believe that it's a real gun, what actually it looks like, and the color are much more cold than on the left, making a completely different atmosphere underlying this picture. So you see here that even though the output is very plausible, it completely changed the reality or the atmosphere underlying an image. And this fact is not restricted to image colorization and might apply also for several computer vision algorithms that have application in creative application of computer vision, for example, super resolution, but also deblurring, image translation. All these automatic image processing algorithms that might be used for creative application might present the same kind of behavior, and we have to recall that a prediction is not an oracle of the future, as well as a perceptually plausible image, which comes from a neural network, does not necessarily represent a real scene and might be very different from the reality. Why should we be picky about this statement? Because there is no technical solution to the problem we are mentioning. There is only a social caveat. We have to distinguish perceptual plausibility from reality, which means that we shall not believe in neural network. We shall not believe that the output of an algorithm is a reality, and we should insist on this point. This is not specific to neural network. It can apply for any kind of automatic image processing algorithm that might be used for creative application, but for other tasks in computer vision. The risk, if we do not insist and if we are not careful on the wording we're using, is to fuel the mistrust of digital information. And as a result, we could have a subtle kind of fake news. You could completely change the reality after having used an algorithm, but without knowing it, without even intending at the beginning to change the reality. And this definitely shall fuel the mistrust in the digital information. Thank you very much for your attention, and you can visit our website.